In this video, we're going to get started modeling the hub or the center section of our Rotiform LHR wheel in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, part 3 of our series, we're going to begin modeling the center portion of our rim. If you're following along, you can go ahead and continue to use your own design. If you've had any trouble up to this point, you can download what you see on the screen here from the description in the video. Now, at this point, I think it's good for us to just take a second to think about what we've done and why we've done it. So originally we got started by first creating a sketch that was the stock rim section for the car that I'm working on. This was a 1984 Mitsubishi Starion. It was an ES model, so it had a 15-inch rim, and it was 6.5 inches wide with an 18mm offset. Now, this is our starting point because I have some solid stuff behind the wheel, the suspension and things like that, that I need to avoid. So I don't really have a lot of options for changing the suspension location in this case. And the way that the car is designed, probably not going to do anything drastic there. But I wanted to make sure that I at least knew where the original stuff was, so that way I knew where I needed my new rim setup to be. Now, keeping that in mind, we started with the profile, or in this case, the Rotiform version 02, which had a flat lip, and it allowed us to create a center section wherever we needed, and the rim profile however we needed. So now I had the ability to add the rim where I wanted it so that it didn't go past the original. And then I also had the image so that I could determine where the center section of the rim was. We also added an image. And in this case, we scaled the image based on in this case, my 4-bolt or 4-lug pattern. So that way everything's scaled not really based on the diameter of the rim in this view, because that's all taken care of by the solid body. And we're going to have to adapt that slightly to what we're doing here. Keeping in mind that if we look at these images, this portion of the lip is going to be about where this portion of the image is. So right now we've got an image that gives us roughly the correct shape and size. And it probably was originally for an 18-inch rim, and we're modeling a 17. So keeping that in mind, this is the position where we're at now. We know exactly what we want to do. We know exactly what we have. We just need to do it. So before we get too far in, I did want to mention a couple other things with sketching and change parameters that we sort of ended the last video on. I mentioned that we can use modify and change parameters to create some expressions. We can either rename things in the sketches or the features that we've created. We can modify how they're linked to each other. And we can also create what's called a user parameter, and we can use that universally. There's another way that we can do this that I think is important for us to mention, just in case you're using this modeling process as learning for something else. So the 16-inch is really just a value for our construction lines. I'm not too worried about doing anything with that. However, this 15-inch is a really big driving value. It's driving the location of this horizontal section of our deep dish rim, and it's controlling the position on the left-hand side. Remember, we used horizontal relationships from the left to the right. So as we change values, as we increase the diameter of the rim, this lip is going to move up. However, the rest of this geometry sort of stayed put. So what I'm going to do is select that value and delete it. I'm going to completely get rid of it. I'm going to go to my dimension tool. And now I want to reference this, which also controls the length of this lip and some other values. I want to reference that up to this point that we're controlling with our values. It turns out to be 1.125 inches. So now what I want to do is I'm going to create a parameter on the fly in this dimension dialog box. So I'm going to call this rim dish. I'm going to put a space, equals, and now you can see the values turn black again. I'm going to hit enter. And now if we go to modify and change parameters, you'll see we have a new one up here, and it's automatically created as a favorite. The name rim dish is what we created. The value is 1.125. And it's just another way that we can create that parameter directly inside of a sketch. So now if we come back to our modify change parameters outside of the design and we modify the rim diameter 18, you can see that everything grows. So if we decided that we wanted an 18-inch rim or a 17-inch rim, because we've changed where those references were, they're no longer going to the center. The only thing that's locked to the center of our Revolve is the 17-inch. So it's very easy for us now to change from a 17 to an 18. So when we make it an 18-inch rim and we bring back the Rotiform, in this case the LHR welded two-piece image, you can see now that the references are looking a bit better. Keep in mind that the image that we're using is for a welded two-piece. This means that the center section is made separately, the lip and the rim is made separately, and they're welded together. We drew the body so that they bolt together. So there are two differences that we need to be aware of. And when you're modeling something like this and you're gathering these references, should be an important thing that you need to figure out. We're going to carry on welding it as a bolt-in section. That way we can just look at the modeling process. But again, these are all the references that you need to figure out when you're kind of planning what you're going to model. So the next thing that we need to do is, well, first let's go ahead and save it because we did change a few things. But then we need to start to design the center. Now, this is where what we picked in terms of the rim is going to be extremely important. Remember this first image that we added from the right-hand side. We were using this as where things are going to bolt together and how everything is going to sort of work out. That was back when we were going to use this as a 17-inch rim, and now we've changed it to an 18-inch rim. Well, the good news is that those values don't really matter. We can always go back and we can recalibrate this. So I'm going to come from this point to this point, and now I'm going to make this 18 inches instead of 17. Noting that when we're calibrating an image, what we're actually doing is we're arbitrarily trying to pick a pixel on the image. You're never going to be able to pick the same exact location. If you have an image that has a reference line, so for example, you can see here, we've got this reference line. This is probably better for us to do because we can pick a more accurate reference line. You can see that's 8.972, which is very close to 9, half of 18 inches. So in a lot of cases, that is going to be the most accurate thing if you've got these reference lines. That's not always the case, unfortunately. Okay, so now we know exactly where the center is. We know exactly where the two pieces are sandwiched together. We don't really need to see body 1 or body 2. We can begin to create this revolved center section. So let's go ahead and do that. Let's start a sketch. Again, I'm going to start by creating my horizontal reference. This is not required. You can do this by revolving about the x-axis because we are centered about the origin. And it's always a good idea for you to model symmetric about the origin if you ever have symmetry. But in our case, I like to have it for a few different reasons. Part of it is just I'm used to the process of having these reference lines. So it's always there for me to select, to add dimensions to if I need to. Another thing is that it can be extremely handy to contain the revolution axis directly in the sketch. If we ever decide to move this away from the origin for some reason, if we happen to go back and let's say that these were components and not bodies and we moved it away, well, the reference for the revolution of that solid body is contained in the same sketch that we draw the profile. So while we can use those axes as our revolution axis, I like to contain them in the same sketch whenever I can. So now that we have our revolution axis, I'm also going to go ahead and take a look at the bodies that we created or the sketch that we used to create them. The reason that I want to do this is because this sketch, the rimlet profile, is going to determine where the center of the bolt goes to hold these two together. And the center of that bolt happens based on the center point of this reference line. Now we can select it and we can project it. It is important to note if we go to our user preferences and we go into the design section, we can actually turn on the auto project edges on references if we want to. That can be a very handy option. One of the commenters brought that up in a surfacing series that we were doing on the Ford Bronco, and it's something I just forgot to mention because generally I keep my install as stock as possible. I don't really change anything, but that is a handy thing which will allow you to automatically project it if you are either constraining to it or adding a dimension to it. For us, however, it wouldn't work in this case. So I'm going to hit P on the keyboard, or you can go to Create, Project Include, and Project. We're going to bring that specified entity, only that edge. We're going to leave the projection link on. If you ever come into a tool and you need more information, you can always hit the little I, and a lot of times that'll bring up just enough to help you understand, or it'll help direct you to in most cases, it'll help direct you to the help file online. So now I'm going to use my line tool. I'm going to find the midpoint, which will be that triangle, and I'm just going to draw this horizontal reference line, hit escape to get off my line tool, and then turn that into construction. If we want to, we can bring the other side in as well. And again, P on the keyboard, enter, and now we can just simply snap those together. So now what we have is the horizontal reference for where that bolt is going to go. But you'll notice that we don't have the inside and outside references. So it might be good to bring those either as the construction line reference or the edge of our sketch here. So P on the keyboard, maybe bring that in, hit enter, and then hide that. So now we have some references. Our bolt, this is the center line of our bolts really. And then we have the inside and the outside where the rim profile is going to be. So now we can begin building this out. I'm simply going to draw a line to connect those two as the start of my profile. Then I'm going to take this one and I'm going to bring it straight forward. Remember, this is the bottom edge reference of the lip or the rim. So I can bring that straight forward. We're not really concerned with things like tolerances in this case. If we were actually building this, obviously we would want to come down a little bit and over, but again, we're not really worried about that here. I'm going to go back to that last point, hold down the left mouse. And from here, I don't think a straight line is really what I want. You'll notice that this could be a tapered edge, or it could be an arc. We really don't know. For the simplicity of the design, let's go ahead and just use a straight line here. We'll bring a straight line down. We'll begin to taper this back, and we'll taper it down here. And we'll come all the way down to our center line. At this stage in the game, I'm not worried about what is happening on the inside. We can go back and remove that later. I'm simply going to come all the way down to the center line. I'm going to come back up, and then we can begin creating this. Now, one problem with going back to the last point and holding down the left mouse button is this is going to create a tangent arc. And that tangent arc isn't actually what we want in this case. So let's hit escape and let's get rid of that. Go to create, arc, 3-point arc. We're going to come from here to about where we think that arc ends. And let's just make it look right. I'm going to use my line tool, L on the keyboard, and I'm going to just draw a line. I'm going to look for my horizontal reference here. I'm not actually creating a constraint, but if you find that point and you just drag the mouse over, you can see that it's snapping to parallel, and it's also helping us specify that point. We're going to go at an angle, and you'll notice that there's a parallel relationship that's automatically created. I'm going to hold down the left mouse button to make an arc here. We're going to pan over. I'm going to hold down the left mouse button again to make another arc, and I'm going to just snap to that point. Go to my constraints, and I'll make these tangent. Keeping in mind that this is the back side of the rim, I'm not extremely concerned with what this looks like because, again, we're not building anything. We're just making references. But it is important that we get the front of it to look right. So this means that we need to decide, are we going to add fillets in the solid or are we going to add them at the sketch level? Now, a couple reasons why we would want to do one over the other. To add them at the feature level is actually a little bit better from a geometry standpoint. The sketches in the the features such as fillet at the sketch level typically are a little bit harder to control. It's much easier for us to dimension just a single point where two lines intersect. So for that reason, I'm going to do it at the feature level. So that means that I can come in and I can find these endpoints. I can make them horizontal. I can add dimensions for things like angles. And I'm going to dimension it to here. I'm going to give this a 95-degree angle. I'm going to dimension this small angle between here. It looks like it'll over constrain the sketch. That's probably because this is vertical. So you see what it did is it automatically put that in parentheses or brackets. And that's because it's a reference. And that's a reference because this value will change. It's over constrained, so we don't need it. And I'm going to go to, let's go ahead and hit D on the keyboard. We're going to go and add an angle here. You see that's 3.7 is pretty close. And then we need an angle here. I'm going to do this all to vertical references. Looks like 156.5 is pretty close. I'm just going to say 156. And then we need to figure out things like the thickness, the location to the origin, how high these references go. So let's go ahead and just start adding some dimensions. 1.25 is a nice round number. Let's go ahead and push this forward a bit. Let's do 0.7. Actually, let's try 0.75, see how close that gets us. A little bit further forward, but that's okay. This right here, let's go ahead and go from our construction line to this point. Right click and make it a diameter. You can see that gives us a diameter value of 3.425 essentially. So let's go ahead and just make that 3.375, a little bit smaller based on the image. And let's add a value here. Now, if we select the line first and select this horizontal reference, you see what it's giving us as an angle. If we select this point first and this reference line and right click, we can still make it a diameter value. 5.5 looks about right, and that's going to be about the right size for the mounting flange, so that looks okay. Remember that the rim that we're dealing with is a 4-lug pattern by 114.3 millimeters. So keeping that in mind, these values seem okay. I'm just going to give this 1.5. That looks okay. This is a vertical line. I'm going to dimension it from here. I'm going to give it 1.5. We also need to figure out things like if there's a tangency here. So we want to make sure that we do have tangency. You'll notice when I do that, things really start to break. So let's do Control Z and undo. Let's undo that diameter or radius value. Let's see if we can apply this without things breaking. It doesn't appear so. These are parallel. Let's go ahead and make one of them vertical if we can. Over constrained. So it really does not like these being tangent. There's a little bit of an issue here. So what I'm going to do is I'm going to get rid of this 1.5 and I'm going to see if I can just drive the tangency without breaking the rest of it and then see what this value wants to be. 1.515 looks pretty close, so I'm okay with that. And then I'm going to give it this height value. Again, these dimensions, we're not actually modeling anything. I mean, we're not producing anything, so I'm not really concerned with accuracy. So keep in mind that I'm just adding these dimensions to make things fully constrained. Hit Control Z. You notice that this does not have tangency, so let's make sure that we have tangency there. These are all tangent, those are all fine. But we need to add some dimensions for the thickness. So 0.76 looks about right. Between these two, it says that it's over defining it, so I'm going to hit cancel. Whenever we get to a point like this where we're not sure what else is driving this, what I want to do is I want to just start to move things around. So from here, I'm going to find this endpoint. I'm going to select this one, make them horizontal. That automatically fixes the bottom. The next thing I want to do is start to figure out what is free to move up here. And you'll see that these kind of move around. So Control Z to undo. If I'm happy with their location, I'm going to pick a point and I'm going to pick another reference. I want to make it so that I'm driving these values off of something else. So that fully defines that. This radius value, I can make it 0.2. This one here, 1.25 looks about right. This one here, 0.4125 looks okay. And now we've got a fully defined closed profile sketch. So let's finish the sketch. Let's go to Revolve. And remember, we have that horizontal reference in that sketch. We're going to create a new body as a full revolution. And then let's go ahead and hide our sketch and bring back the other bodies. So now you can see that we are starting to design the rim. So we've got the center section. It looks a bit funky right now, but this is exactly what we're looking for. If we go to Inspect, Section Analysis, and we take a look at this from the side, what we've done is we've replicated the flat lip sandwich, and we've replicated the rim portion where it needs to be, and we've replicated the center section where it needs to be. This is the starting point for getting rid of all the other geometry. In some cases, even if the two pieces are, or three pieces in this case, are all welded or forged or cast together, you might still want to design it like this because it's easier for us to remove material from the center without having to worry about how it intersects with the lip of the rim at this point. The section analysis looks good, so I'm happy with it. I'm going to rename body 1 front rim lip. I'm going to call this one rear rim lip. And I'm going to call this one hub. And then I'm going to call this hub revolve. And again, we're not dealing with many bodies or sketches, so it's a good idea for us to rename those. The last thing that I want to do before we finish this video is I want to add some fillets to the front. Remember, everything on the back was nice and smooth. We used arcs and lines with tangency, but up front, we left these as straight intersections. So I'm going to go to fillet, and I'm going to just add a 1/2 inch fillet. You can see that's pretty small. I'm going to hold down Control or Command if you're on a Mac, and I'm going to add one there. And in the center here, I'm going to do that as well. Now, this is important to understand that when we're adding fillets after the fact, it can be very beneficial to add some sort of geometry before we do that. The reason that's beneficial is because we can use these as projected references in other sketches for precise locations of features. In our case, we're not going to worry about that at this stage. We may or may not have to go back and create some sketches or features before the fillet, but at this stage, that is pretty good. Before I go too much further, we obviously do want to save. Let's make a quick save. And let's take a second to change the appearance of some of these so that way it's easier for us to identify the differences. The hub itself, I'm going to right click and go to Appearance. I'm going to look down through my metals, and for right now, I'm just going to go to a gold color. Gold, I'm going to drag it onto that body, and I'm going to close it. So you can see here now that the gold portion of the rim is behind that lip. If we hide the front lip, you can see that we have more rim in there. And this is going to help us identify the differences between all the bodies. But great first start. Let's go ahead and go to just a home view. Once again, let's take a quick look at the section view. I'm going to say OK to turn on the section view just so that I have it in an analysis folder. You can always hide or show it at any point in time, but it can be handy just to have that to look through. So at this stage, everything looks pretty good. I'm happy with the results. We've made some good progress. We now have the 3 pieces of our 3-piece rim, and we can begin designing all the cutouts and openings, the location of the lugs, and all the other details that we need. But at this point, make sure that you do save so we don't lose any work. We always have something to come back to. If you have any questions, please ask them. And as always, thanks for watching, and we'll see you in the next one.